Hi everyone, and welcome to our first civil infrastructure webinar of 2022, and happy Friday as well. It has been a long time in the making, but I do apologize. It has been quite hectic on my end. I did get a lot of messages from the users out there as to when the next webinar would be, or when will the webinars be kicking off for this year. So finally we are here. I have been traveling quite a bit. I'm currently recording this webinar from a mine outside of South Africa at the moment. So I do apologize if the audio isn't that great or if you see anything popping up on the screen. I have just my laptop, no second screen, so it's quite tricky to record. But hey, we are here, and today we're going to be looking at sewer design. So for those that have missed the previous parts of the series, they are all uploaded to our Baker Baines YouTube channel. Actually, all of our webinars hosted by our technical specialists are on there. So whether you are in the AEC or PDM industries, please do subscribe and turn on the notifications so that when the webinars are uploaded, including the one here today, you will be notified so that you could always go and rewatch it, engage the content, and apply it as to your design environment. So a little bit about this webinar series. You can see it is 6 parts, and we are looking at different design aspects, looking at site, roads, stormwater, sewer, water, as well as design visualization. Of course, today we're looking at sewer design and the technologies that we are using in the series. The ones that are in the red rectangle are InfraWorks, Civil 3D, and Devotech IDAS. We've been using those quite a bit in the series. They are the front runners, if I could say. With the technologies outside of that, we might touch on them depending on the visualization stage. So I will try and bring them in maybe in part 6. Of course, I am your host. I am Shoaib Yunus. I'm the BIM technical specialist for civil infrastructure and mining here at Baker Baines in South Africa. Those are my credentials on the screen, but what I do at Baker Baines is that I am involved in numerous projects involving BIM for civil infrastructure, GIS, CDEs or common data environment, reality capture, scan to BIM, as well as virtual reality and visualization. And of course, if you would like to reach out to me directly, you can contact me at shoaib@bakerbaines.com. So just a one slider on who we are as Baker Baines. These are the 4 main segments that we actually specialize in. So whether it be scan to BIM, design software, business process improvement consulting, as well as blended learning, we have them all covered. And you can see we practically have a widespread targeting all of the main industries out there. So architecture, civil, structural, energy, process plant, as well as manufacturing. We are an Autodesk accredited authorized training center, and we do provide training, be it in class, on site, at your premises, or virtually, which has been predominantly the case with our current situation. However, things are getting better, and we really look forward to having in-person training soon. Of course, if you are one of those designers like myself that really like to learn on the go or as the project dictates, CAD Learning is your tool. It is an online learning portal with up to 50 plus Autodesk software that have been uploaded on there, as well as a course that I have done personally on Scan to BIM for buildings. So how it works is, let's say if you want to learn Civil 3D, there are pre-recorded videos, classroom videos with the exercise files that you would practice as the person is instructing on the screen. You can then take a skills test at the end, and let's say you get 80%. The technology is quite intelligent where it will create a filtered playlist looking at the 20% that you got wrong. So it's really targeted learning, and of course you can upskill yourself on your weak points and become a much more better designer. So this is a quick snapshot. These are the technology partners or brands that we believe in and we partner with, and it really is out there to help you design and make a better world. Now let's look at today's session, what we're going to be looking at. I'm just going to touch quickly on the industry perspective because we do need to understand the challenges that we face and why you would need to use BIM technologies. Thereafter, we dive directly into the topic at hand, being civil infrastructure design or development for sewer design. I'm going to take you through those points that you're seeing on your screen, and then of course we're going to wrap it up and let you get on with your day. So let's start off with the industry perspective. What challenges are faced in civil infrastructure development or municipal engineering? So the first one is design complexity. I mean, with the rise in urbanization, more people moving to the cities, we need much more infrastructure, much more faster, and we need it much more futuristic to a sense, right? And that could be quite complicated, especially if you're dealing with a large development site. It can be quite messy with a lot of design components interacting. Now, if you're using 2D or unintelligent technology to do that, it can be quite a nightmare coordinating, speaking from experience. That brings me to my next point, actually being the design coordination. So ensuring that all involved is on the same page, making sure that the civil design complements the architectural design, complements the structural design, and so on. Everyone's design needs to complement each other so that you get a beautiful project at the end done successfully. So coordination can be quite an issue, and if you are using unintelligent technologies or not using the BIM methodology, you're going to really struggle. When it comes to collaboration, again, sharing of the data, ensuring that there is a single source of truth, making sure that everything is housed under one environment is quite tricky. If you're using a host of different collaboration tools, so email, Dropbox, all of these FTP sites, they're not really catered to design files. And with the BIM environment, as well as the Autodesk Construction Cloud, that has been solved where all of the team can be coordinating through one platform. Of course, you do need the correct design technologies. I mean, if you want to build something that's really complex, yes, you can use AutoCAD, but the challenge and the time and the monotonous nature that comes with it, it cannot be removed. And this is where BIM technologies surpass that, where it's intelligent, dynamic, parametric, as well as it has a visual component. So that brings me to design visualization. So translating the technical engineering to something that is simple and visual. Generally, the people that are in charge of signing off on the project or are providing the capital are not engineers, so they really are interested in the end result, and this is where visualization comes into play. So if you're going to give them 2D data or just 2D plans, it becomes quite hard and cumbersome to actually visualize that in 3D. It might be easy for you as a technical person, however, when it comes to others, it's quite difficult, and this is where BIM again wins, because the visualization is, or the 3D nature of it is a byproduct. So really important that you use intelligent technologies, and BIM is the way to go. So now that we have a quick idea as to the challenges that we face, let's jump into part 4, which is looking at sewer design. Now a quick recap from part 1 to 3, just to put you into perspective. This was our design brief. As an engineer, I'm used to working with stuff like this, so I thought I would create one, or create a scenario that we can all align to. So we were the consultants that were appointed for this residential development project. You can see it is in Ballito, Dolphin Coast in KZN, South Africa, and we had to tackle all of those topics, being site, road, stormwater, sewer, water, and visualization. So we have done or completed the site design successfully. We've done the roads for the development. We've done the stormwater design, which was the last webinar. And today we're going to be looking at sewer design. And of course, the intention here is to show you that how BIM technologies can be used for all of the above. And of course, today being sewer design. So let's jump right in with the first one. So how would you convert Polylines to a sewer network? Now, we all use Polylines or Polylines, however you would like to pronounce it, where we would draw the sewer network and then we could convert it. Of course, you could go directly and use the pipe interface, but Polylines is the most popular one used in industry. So let's see how this works. So as you can see there, I have drawn my polyline. It is in red, and that is going to on an AutoCAD layer for the sewers, and I've also added the direction labels for the arrows. And as you can see, that portion there is my outfall, and all of my sewer lines need to be gravitating towards that so it flows successfully. And you can see all of them are actually moving or are designed in the correct direction, besides the one on the top, which is here. You can see it is actually going in the opposite direction. That is incorrect, because it all needs to drain towards the outfall location, and as you can see, it is clearly in the opposite direction. So how do we solve that? Of course, you could reverse the polyline if you'd like, but if you had a lot of them drawn in a different direction, it will take you quite a long time. So what we're going to do is we're going to use IDAS for this, and we're going to go to the sewer wizard. I'm going to give it a name. I'm just going to call it sewer. And of course, you would need to select your site or your reference surface. And then, of course, the great thing with IDAS is it has our South African catalogs built into it. Now, I've been using Rockler throughout this series, so I'm going to probably continue with it. But you can see that there are a lot of popular catalogs that are already predefined and created for you using the Devotech Civil 3D template as well as the IDAS add-in. Now you can see here we have different pipes or different catalogs. Let me scroll down a bit for sewer design, and depending on your application, your size of pipe and so on, you're more than welcome to go and select whatever you'd like, be it UPVC, UPVC and so on. I'm going to stick with probably the sewer class for Rockler, the 75D, and maybe we can use a 300. Of course, you can change the pipe sizes later. A lot of the principles have been covered in the previous webinar, being sewer design, so this one's going to be very quick blitz, if I would say. So if you do get stuck, I will show you where you can actually go and see some of that stuff. So I'm going to highlight my entire network, and I'm going to hit enter, and you'll see after a few seconds it will convert those polylines to a pipe network. So you can see there's the manhole or the junction structure clearly there, and if I zoom in, you can see there is quite a bit on there, but we did not reverse the direction yet, so I will show you how we're going to be doing that. So what it has done already is, you can see here, if I select that, it has created the pipeline or the pipe network along with the structures. So just so that you could see it better, I'm going to isolate it, right? So again, your AutoCAD does come into play here, and that's what makes Civil 3D also much more easier to understand, because you can still use your AutoCAD shortcuts in Civil 3D. So I will isolate this network, and this is the result. Okay, so we have our network. So just to show you that it has been done correctly, and of course I've got my outfall structure at the top there, and of course I've got the rest of the structures. Now what I'm going to do is I'm going to add a label just to show you the flow directions currently of the pipe network. Okay, so again, the Civil 3D template created by IDAS is absolutely brilliant. It has all of these built in for you, and you can see it gives me the directions of flow of the pipe, and you can see the one on the top is still in the incorrect direction. The rest are all flowing or gravitating towards the outfall, with the pipe or the branch on the top not. Now how do we fix that? Devotech IDAS has an amazing tool called Regrade Network. Now what this will do is it will allow you to go and select your sewer network, right? So let's just do that again. Or we can also select the flow directions tab. Let's do it that way. So we're going to go and select the flow direction. I'm going to select my outfall location, or you could have told the software to compute it based on the lowest elevation. In this case, our outfall is defined. So I'm going to go here and I'm going to select the outfall location there. That pop-up is due to a surface that was not updated, so don't worry about that. And then of course I would select my site or reference surface, my match location in terms of the pipe, whether I want it to be to the crown, to the invert, or to the center, and Once I do that, the software will start computing and regrading the network. And if I go to that pipe, it is now fixed. You can see the direction of flow is now correct, and the rest of the pipe network as well, in case you miss something, will be gravitating and flowing towards that outfall location. So just in a few clicks, I was able to resolve the entire network. And bear in mind, this is the same file that has the stormwater network in it. So you don't have to do them in separate drawings. You could do them all in the same drawing. However, you might have to gauge in terms of the size of your drawing or the specs of your computer, but they all can be done in the same drawing. Mine is just switched off so that you could see the sewer design much more better. Okay, so in a few clicks, we converted polylines into a pipe network. What about the long sections? So let's see how we would do that. So I've isolated this again so that you could see the network correctly. And I would also add on the labels for the pipes as well as the structures. So again, I would just use our normal Civil 3D annotate commands. And if I click on the network, it has added everything into it. It's good practice to label it in direction of flow as well as per branch name. However, if you're not concerned with that, you could leave the labels as they are, but you could see mine is already labeled correctly. If you have this overlap of labels, you could always move them. That's not an issue. And of course, you could also adjust the scale of the drawing so that the annotative text updates accordingly. But you can see they are all labeled sequentially besides one of them. I've left one of them just to give you an idea as to how you would relabel them. So for example, here you could see 84 and 89, that is not correct. So what I would do is I would just use the normal utility tools in Civil 3D to rename these network parts, right? So I would select the start of the branch and I would select the end of the branch. Now the end of the branch does not have to be a structure. It could be a pipe like you've seen there, and it highlights everything in between. Now once we've got that, you could use whatever naming convention you like. In this case, I'm saying it is, for example, the 3 standing for the branch number and the numbers on the right hand side standing for what sequence they are in that branch. So there we are, done and dusted. So it's pipe 3.1, meaning in branch 3 it is pipe 1 and so on. So that is done. Of course it's optional, but I normally do it because I like my drawings to look crisp and in order. But of course, if you don't want to do it, it's up to you. Right. So now that the branches are labeled and we go to the pipe manager, right? So we went to the IDAS pipe manager here. This is the IDAS interface, which opens once you hit the pipe manager option on Civil 3D. You can see if I zoom in, it will give me a preview. I could toggle on and off certain things if I wouldn't like to see them. That's just for the visual nature or the plan view that you would normally see. And of course, that is our development. And if I select any object, so for example, if I go to the outfall, in this case, you would need to select the outfall, right click, and you can either say set a start or set a profile, whatever you would like it to be. Alternatively, when we're going to be generating the long sections, I would select that. And again, I would right click. You would see there are different options. You could swap that structure. You could make it the end of your branch, start of your branch. Alternatively, we could then go to the Civil 3D option on the top and we can say create profile views. Now, once we click on create profile views, it's going to ask you for an insertion point. You could click somewhere away from your plan view, or you could even create a marker in Civil 3D via a polyline so that you know where you would like to position your long sections. Now we will label them accordingly. I will use the start and end structure names because I've labeled my branches in the correct direction. I could have it overlapping, but I'm gonna untick that. And of course, I can then go and select from the multiple styles available using the template created by Devotech. Okay, so again, I will create the style and the band set style. Quick and easy. I hit OK. And after a few seconds, you will see that it will start processing and those profile views are now created. Now they might look like that in this interface. I will just hit update, and then we will come back to Civil 3D, and you will see that if I zoom in, the long sections for the sewer network are now done. You can see they look pretty good, pretty neat, and of course they are within the NGL. Of course, as you've seen in the stormwater webinar series, I could always use the adjust invert option, where it will all automatically adjust the inverts for the entire network so that it is within the NGL and it does not exceed it, right? I can also use a lot of different options that I've used in the stormwater design series, where I could go and add structures, swap them, delete them. The same options that we've used are applicable in the sewer network, right? So for example, if I wanted to insert a structure, I can go and select the reference surface. I would like it also to interpolate. So for example, let's say I want to insert a manhole. We've been using a meter. I would like the software to interpolate the slope based on where I click. I simply then just select the profile view that I would like to deal with simply by clicking the grid. I would click on the pipe or the option where I would like it to be. It will ask me to select the pipe to divide or the insertion point, and once I click, there we are. That structure is put in perfectly and it's not going above the NGL. You can see it called it manhole 92. I might have to go and rename that depending, right? And if I wanted to find as to where it is, I would use the find part option in the IDAS ribbon. Okay, I would go and hit search, and you will see it picks it up in plan. If I click on it, it takes me to where it is, and if I go to profile, it will zoom as to where it is in my drawing. So very, very helpful tool in that case. And of course I could then go and rename that if I would like. So for example, if I go to annotate, I go back to the labels, I can go and add a network label, and maybe I just want it for that single structure. I don't want to add the labels again because I've already added them, right? So I can go and select maybe a single part, plan, and then I can go and decide as to what I want. I can hit add, and you'll see that it is manhole 92, so it is the correct one. Of course, I would need to rename that in conjunction with my branch, but I'm just going to leave it like that for now. But you can see that the long sections have been done with a simple click of export to Civil 3D using IDAS, and it looks pretty good. So now we come to the segment where we would need to add the sewer connections or house connections to the sewer network. Now I am going to give you a quick overview as to some of the functionality that is available in IDAS, but stick around to the end of the webinar because I'm going to be showing you where you could access a range of very in-depth videos on this topic, as well as various other pipe networks and so on. So here we are. We have the pipe networks or the sewer network done and dusted, right? And we have the house connection button on the left, as well as the tab on the top in the IDAS Pipe Manager. Now you can see there are three creation methods that are available when it comes to the sewer connections, and of course the private sewer type. We can also specify the minimum size of the plot to be considered, as well as the peak factor and infiltration percentage. You can see those are pretty spot on as to what we would normally use. And of course, if I select a parcel in the table, it will highlight in the plan. I could also select it in the plan and it will highlight. So it gives you an idea as to which parcel you are dealing with. You can see I was playing around with parcel 74 and I created a connection, a private sewer house connection. But what I would do is I am just going to delete it pretty quickly. Right, I think there's just one more segment. Let's just make sure that it is removed correctly, and here we are. So it is done and dusted. Now what I want to do is just want to add a house connection only. So I can hit the add HC. I will use the default option that is normally set on the top. Alright, there we go, house connection, and we hit OK, and there we are. SC standing for sewer connection, right? So that is what it is, and you have a profile view indicating what has happened on the left hand side. Now, what if I wanted to add a private sewer and a house connection? I could simply hit that button there, and you will see it will generate it accordingly, and you can see it is going along the border and tying into the sewer connection there. And you've got the updated profile view on the left. Now you have a variety of other options, so let's play around with some of them. You can see, for example, if I change it maybe to lowest surface elevation, let's see what we get. So I'm going to leave it along the border, and if I go to add, we will see that it will change, where the house connection now goes to the lowest point of the plot. I'm sorry, I think I clicked somewhere else. Let's just go back to 74. There we are. And you will see that it goes to the lowest point with the sewer connection linking to that. Let's change it to a different option, maybe lowest elevation. That was actually our default one, or the first one we used first. And you'll see it does come back to its original state. And maybe let's switch it up a bit. Let's go to high to low point for the private sewer. Let's see what we get. So I'm going to go back to parcel 74 or plot 74, and this is, let's see, so we can hit add, and you will see that it joined it from the high point to the low point, and then it links to the sewer connection. So you can go and play around with all of these options as you would like and see what you would get in the long run. Pretty simple, pretty straightforward. Now you can also move, you could remove the house connections, you could remove the private sewers. All of that can be done quite easily in Civil 3D. Again, I wouldn't have time to show you that currently, but I will definitely show you where you could go and check out those videos that have been done pretty brilliantly. Now, what I can do is I can go and add the house connections or the sewer connections to all of them at once. So what I've done is I've selected all of the parcels in the table, and as you can see on the bottom right corner, it is adding the private sewer and house connections to all of them. This might take a few minutes, or a few seconds rather, not minutes. If it does take minutes, you're dealing with a really big development. This will probably take about 20 seconds or so, depending. Alright, so let's see. It will start displaying the sewer connections very soon. You will see a dashed orange line throughout the development. So you can see it is starting to do that accordingly. Alright, and there we are. As you can see in the plan, all of the house connections and sewer connections are now being generated, and the display is just updating, and there we are. We have each of them with their associated profile views, and they have been done along the border. Pretty neat, pretty easy. Like I said, you can definitely edit them. If we go back to Civil 3D, all we got to do is modify those orange polylines in Civil 3D, and we add it back, and it will update the system. I can add the house connections to my profile views. I'm not going to do that because it becomes quite cluttered, but you do have that option where once you do, it will be updated and visible on your profile view. So that is it. We have the house connections added quite easily. Now, how could we go and set the income group? Now, in IDAS, we do have an option, right, to set the income group. So, for example, here, if we go to the inflow groups, we've got high, low, and medium. Again, if you look at the red book, you would find this. You can also edit it, and you can also add your own inflow group if you like. Now, this is going to help us from a demand generation or an analytical perspective. And what I'm going to do is I'm going to highlight again all of these parcels, all of these plots, and I'm going to set the inflow group. So let's say I want all of them to be high. Of course, you could have them different, high, low, medium, but just to save time, I've selected all of them, and now we've created an inflow group of high. Now, what this is going to do is it's going to help us to do the analysis, which comes next. So let's analyze the sewer network using the Devotech IDAS Pipe Manager. Now we have our house connections done and dusted. We have our inflow groups set, right? I just wanted to show you that under house connections, we also have types. So these are based on minimum depths, maximum depths, offsets, and so on, right? So minimum and maximum offsets, and you've got type 1 to type 5, and you also have the option to add your own connection type. Now, if you don't know what this looks like, the tab on the right hand side gives you a schematic of exactly the dimensions and how it is calculated. So very, very informative from that perspective. So if you ever do get lost, please make reference to the tab on the right hand side. So I'm going to toggle it back to the plan view and maybe resize those windows. And what we will do is let's have a look at what we have. So for example, I can clearly see something's wrong with that profile. You will see it in a bit, right? But we do have options to grade and to change certain slopes and so on in the top ribbon, as you can see there. Okay, so all of these are editable based on your requirements. And of course, you've got different profile views for different branches, right? And of course, if I do select a pipe, it will also show me in plan as to which pipe I am selecting, and it will also flag it. So for example, this pipe is too long, maximum distance is exceeded for the structure, so it's a really good check. If I go to the structures, I've got a list. I can also specify different patterns and series that can be created in IDAS. I can also check out the conduits. You can see that the minimum diameter of the pipe is incorrect. It's below, right? But we'll fix that shortly. And I also need to assign a Manning's roughness coefficient. Now, based on the material that you're using, Manning's has different ones. They could be 0. I think it starts from 0.011. It goes to 0.015. I might be wrong. So let's maybe use 0.012. Of course, you will know the exact factor. You can add that in there as your roughness coefficient. Now, how do we fix that? You can see that the pipe diameter is smaller than 450. Now, let's go and see where we could go find that. But before we do that, when it comes to the hydraulic parameters, we do have different options for analysis, so steady, kinematic, and dynamic. And of course, you can go and set your duration, your dry days, and so on. So all of these are very customizable. When it comes to dynamic wave, you can also go and toggle the settings. But when it comes to the analysis, you can see this is where we get the minimum diameter, inner diameter. So if I change that, this will update. So let's say the minimum diameter needs to be 250. And once I do that, you can see the hazard or the flagged symbol goes away because it's now compliant. So it's a very, very nice way of doing things. Now, of course, you can go and toggle or create whatever you'd like here. So please check out the tabs and see what is available. Now, I want to go and run the analysis. Okay. So I could either right click anywhere in the interface to do it, or I could go and click on the Analyze button like I've done, and you see it has failed. So let's see why it failed. So if we go to the reports and we go to analysis reports and we have a look, you can see the errors there. Now the great thing is the errors are also highlighted in the IDAS help file. So if you don't know what it is, you can always check it out, but it means there is an adverse slope at those certain points in the network, meaning it is sloping in the wrong direction. Now that is a problem, especially from a construction perspective. You do not want your sewer to do that. So the report gives us an idea as to how to fix it. Now we could go directly to those parts. We could simply use the find part option and fix it. Or we could do it this way. So let's see, if I go to find part, I've done it previously, so I'm not going to do it again. But I could just regrade the network. So I could go OK, right? Regrade the network. I can then set the min max cover, the target surface or reference surface, as well as to which match location. I can play around with the slopes if I like, but I'll hit OK. And once I do that, the software will then regrade the network accordingly, and that should resolve the adverse slopes. So let's go back to the pipe manager. So we go back here, there we are, and you'll see if we go to the profiles, everything now is sloping correctly. Of course, you can make some adjustments depending on your cover requirements, or if there's a too steep of a slope, depending. But you can see everything now is actually sloping in the correct direction. I do not see any adverse slope there. Right. So let us go and analyze. So right click and analyze. And here we are. It is completed, meaning that we didn't have those errors. Now let's go and check out how the report looks. So if we go to the analysis report, analysis, I'm getting tongue-tied now, analysis reports, you can see it gives you all of the readings as you would go down, depending on what you had inputted. And the great thing is we can also get the bill of materials. So it uses excavation parameters that you can edit. Okay, those values are editable, but they are as per SABS 1200. But I'm going to click calculate. And once I do that, you'll see the calculation is complete. I go to the excavation volumes and it gives me the table. Of course, I can change the bidding classes if I would like, but then I would need to rerun the calculation. I mean, because it needs to update according to that. And then, of course, I can get a variety of different summaries. I can get the excavation length, a length summary, as well as the number of pipes and structures in my network. The great thing is I can also export it to Excel. So I will just call it sewer. There we are. And once I've exported it to Excel, I'm just going to fire up my Excel very quickly. Alright, so, and then we can open up that file. So let's go to open. And let's go browse my desktop quickly. And there it is on the top, sewer. And I hit open. And this is what you can get. And you can see all of that data now is exported to Excel. And you can use it however you like. And that is it. So again, you have those variety of tabs at the bottom. And you can include it in the report. You could make it look a bit better, edit the styles. It's up to you. But you have all of the data that you require. Now, when it comes to much more detailed or in-depth videos, Autodesk has all of this on the training on demand. So if you go to the Devotech website, there we are, you can go to education and you would click on training on demand. And Antonin, who has done brilliant videos, has created a lot of content on different topics, as you can see below. You would need to create a login. The login is free or sign up. And if I click on, for example, sewer or stormwater, whatever it is, it will give me the videos. So let's click on sewer, for example, and you will see that there would be a lot of different topics from fundamentals right up to advanced or newer topics as the development of the software progresses. And you can see all of these videos are readily available for you. So when you are doing design and you might need to look at it much more in depth, you could always refer to these videos. You could use this webinar also as a reference, but you have enough resources, including the built-in help file, that is available so that you could use the software to your advantage. And that is it for today. So let's look at our closing takeaways. So what we had done was we converted the Polylines to the stormwater to the sewer network using the Devotech IDAS sewer wizard. We then generated the long sections quite easily using the pipe manager and we exported it to Civil 3D, where you could apply edits to it either using the IDAS functions or using the graphical options. We then created and looked at different methods of how you could modify the house connection based on different criterion. Again, if you want to check out how you would like to move those lines or edit it, please refer to the Devotech website. I think it's done quite brilliantly and it emphasizes the different options that you have. We then set the income group based on our population, and thereafter we analyzed it. You saw that we got an error or it failed initially. We then fixed it by looking at the report error, and then it was successful. So how can we help you? So this is what we believe in. We solve our customers' problems through digital transformation, helping them to design and make a better world. And of course, by using the correct technologies, you're definitely going to do that. So there's three ways that we would recommend that we could help you. We could help you do it yourself, where you could use CAD learning, where you could learn at your own place in your own time, and you could learn a variety of different Autodesk software and become a versatile professional. So this will be based on you. You could subscribe to the learning portal, and then you could learn as much as you would like. The second option is let us show you. So you could attend the training courses that we host based on our training calendar. If it is customized, you can always reach out to us. We could put together a tailored playlist or a tailored content or outline for you. And if you need the basics, we also have Kickstarter courses. So from a training perspective, we can definitely show you. And the third one, which is my favorite, I would say let's do it together, where we could show it or we could do it with you. So maybe project-based training, a pilot project, that type of things. So if you would like to get your teams, your processes and technology workflow standardized across your departments, we can also help with that so that things work efficiently in your design office. And if your tasks are overwhelming or too complex, you could always reach out to us and we could propose a way forward. So you can see that there are 3 different options that you could leverage from us. We base this on our IADOT methodology, which is basically we assess your current situation, we educate you as much as we can, and we consult with you where and if needed. We also believe in the methodology that we teach you to fish for yourself so that once you get up to scratch, you can be independent. So if you would like to reach out to us or follow us, those are our handles. We've got LinkedIn, Facebook, Twitter, Instagram, as well as YouTube. Our Baker Bains YouTube channel, which this webinar will be uploaded from. And of course, our clients have access to our support desk, which is open from 8 a.m. up to the time that you're seeing there. And of course, if you would like to reach out to me directly, anything civil infrastructure design and scan to BIM, VR visualization, whatever you're seeing on the screen, I can help you with. You can always hit me up. My email address is on there, so shuaib@bakerbains.com. So you can see I delve with a lot of different products. I'm not an expert in all of them, but we can definitely figure out something and help you. So how I can help you is I can help you with consulting, software training, scan to BIM, process analysis, demos, presenting at probably events, or if you would like us to participate, you can always reach out to me. Webinars, and of course, if you would just like to have a chat, you could always reach out for me. And that is it for our first BIM for Civil Infrastructure webinar for this year. I hope you've enjoyed it. I hope it was a quick overview, give you a good insight as to what's available, what's capable with IDAS and Civil 3D. And keep your eyes peeled for part 5. I cannot commit to a date yet, but it should be pretty soon. So take care, have an awesome Friday, and I hope to see you for the next webinar.